Hi guys, interrupt was a little bit of a challenge for me because I'm a hardware guy. As a hardware guy, we have the CPU, we have a main, and the only thing we do with the CPU is reads and writes. So we have one software, one program in the main, we read and write and everything is fine. But we sometimes have events which we want the CPU not to wait for them but to address them as they occur. So this we need an interrupt. Now every interrupt needs an interrupt controller to control which interrupts, if we have more than one, and tell the CPU which one was available and what to do with it. Now once the event occur, in this case interrupt, the CPU stop what it's doing and save the place in the main program. Then it jumps to the handler, execute the handler, and once the handler was executed, it goes back to where it stopped and continue the program. Now we use two kinds of CPU. One is the MicroBlaze. The MicroBlaze is a very simple CPU, so it doesn't have its own interrupt controller. So we add it in the design, and now we have an interrupt controller and we need to address it. We will work also on the Zynq. Now the Zynq is a SoC. It's a system on a chip. It has CPU, but it has other peripherals inside the SoC. Among them, we have the GIC, which is the interrupt controller, general interrupt controller, which connect to the interrupt, and we will use outputs as the UARTs. One more thing is that I'm generating the interrupt by a push button. The push button is a very slow interface and have to be pushed by hand, so I might tremble and it might take a while, so I'm adding a debouncer. The debouncer is just an edge detector which detects the rising of the push button press, and then it blocks the push button for 26 bits of counter, which will remain about a little more than half a second. So the one push was transferred, and then it's blocked for a half a second, and after a half a second we can generate another interrupt. We'll start by opening Vivado. We'll create a project. We call it int proj, and we'll direct it to a demo folder I prepared. We'll create a work directory here, and we'll have our directory here, no RTL, and board the RTZ720. Now that we have a project, let's create our block design. We'll call it int block design. We'll direct it to the same location. And here is our block design. First we need the Zynq. Run block automation, and let's look at the Zynq. Here is our interrupt controller, and we need to enable the interrupts. And since we're not using any peripheral in this project, we will disable the XI master from the Zynq. Okay, now let's bring the MicroBlaze. run block automation, 64 Ks of RAM and not cache. And we have it. Now let's bring the interrupt controller. Here is the interrupt controller. Some of the functions are here for level interrupt and other stuff. We'll run block automation. We'll stay with the default and make sure that we connect it to the microwave through a new AXI interconnect. Now we'll connect the interrupt output of the controller to the MicroBlaze, and that's it. Now the MicroBlaze doesn't have any outputs, so on our boards we have the RGB LEDs and the 4 regular LEDs. So we have this tab for board and we'll drag both of them into the canvas. So we have a GPIO with 2 ports and we run connection automation to the MicroBlaze through the interconnect peripheral, and we have it, and we have the address 4000. Everything is cool. Now we need to address the interrupts. Now, as I said in the beginning, we need a debouncer, so we'll add a source. Create a source. We'll call it debouncer and we'll direct it to a new RTL directory and we'll start writing it. For the debouncer, we need an input of a clock, we need an input of an RSTN, we need an input for the push button, BTN, and we need an output for the int, but int is a special word, so we'll call it int out. Now let's write the debouncer. First we need a register of 26 bits, 25 to 0, and we'll call it count. Then we'll write it always at pause edge clock or neg edge RSTN. If RSTN, then we'll start at all ones. Now all ones, because we have 3 at the beginning, will be 26 bits. It will be 3 and FF, FF, FF. Next, else, if the counter is counting, which means it hasn't reached FF, we'll just keep counting. So nothing will happen, and this will block any inputs from the push button. Else, if the BTN is high, then we'll start the counter by writing 0 to it. That's it. And now we need to assign the output. If the counter is 1, which means we press and a cycle later, then we'll generate an interrupt. Otherwise, we're at 0. So this is our debouncer. And now we have to put it in the system. So we'll use the add module like I showed you in my DMA project. And since we need 2, I'll copy this so we have 2. And I'll join them with a concat. So we'll take debouncer 0 to input 0, debouncer 1 to input 1, and the output of the concat will address the interrupt controller in the MicroBlaze and the interrupt input in the Zynq. Next, we add connection automation to connect the clocks for the debouncer, and the only thing left to do is to extract the BTNs. We'll extract the 0 BTN, then we'll extract the 1 BTN. And that's our block design. So now we have the RGB LEDs output and LEDs output, which the Vivado is familiar since he knows the RT board, but he doesn't know the BTN. So we'll create a wrapper and then we'll go to the schematic of the board and we'll see that the BTN 0 and 1 are connected to D19, D20 in a 3.3 volts bank. So we need to add the constraint file. We'll add a constraint file. We'll call it pins. We'll direct it to a new created directory constraint. And we add the constraint for the pins, and we'll make sure that the pins we use in the top level in the wrapper are the same as the pins here, BT0, BT1, all good. So that's it. Our design is ready. I'll synthesize it and I'll stop my video for the synthesize and I'll come back when it's done. Okay, my bitstream is ready. Let's view the reports. We don't have any timing issues. So we'll extract the hardware with the bitstream. We'll direct it a newly created directory, software, and we'll start Vitis. Now from here on the rest is software, so we'll direct the Vitis to our software directory, and we'll start it. But this video has turned out to be quite long, so I'll start working on the MicroBlaze software on my next video. See you there.